I liked the last one.
Okay, here we go. We have section 4.1, section 4.2, section 6.1, and section 6.2 to cover before the end of the year. We are going to be able to do that. So we'll cover one section today, a section Tuesday, and 2 on Thursday, and then our final on Friday. Yep. Your final is only over these sections: 6-1, 4-1, 4-2, 6-1, and 6-2. It's not like an actual final. No, you don't have to take it. That's just a quiz. Okay. All right. So, inverse functions. I got to teach inverse functions in here. So, yes, I have to teach inverse functions. Y equals 2x plus 3. This is, yes, I'm recording this. All right. So, this function, now we're going back to algebra 2 again. Algebra 2, y equals 2x plus 3. The function looks like this. 4, yeah. Sure. Oh, why are we graphing again? This is so hard. Okay, 2x plus 3 has a y-intercept of 3, right? It has a slope of 2. So I go a rise of 2 and right to the right 1, or down 2 to the left 1. So it kind of looks like this, going like this. Okay? Now bringing back a little algebra 2, and so you know what you're doing on the ACT test. What's the inverse of this function? How do we find an inverse of a function? Yeah. Switch a y and x. Good job. You did this not long ago in algebra 2. So then, if you subtract 3 and divide by 2, y equals x minus 3 over 2. So what points would that be? Well, what? Okay. This is the inverse. These two functions are inverses of each other. So if we put in a 0 for x, we get like negative 1.5. Okay, that's not a very nice number. What if we put in like 3 for x? What do we get? 0 for y. 3 minus 3 is 0. 0 divided by 2 is still 0. If we put in 1 for x, what do we get? Well, what's 1 minus 3? Negative 1, or negative 2 divided by 1 is negative 1. So 1, negative 1. Okay? So it's a function that looks like this. What do we know about inverse functions? Not that they're ugly. That they cross the line y equals x. Right? Did you not know that?
No, I did not know.
So then, you did not know that these ordered pairs 0, 3, negative 1, 1, negative 2, negative 1, if you just switch them around, they're these ordered pairs: 3, 0, 1, negative 1, and then negative 1, negative 2. Did you not know that?
No.
You should have learned that in algebra 2.
We did not.
Okay. Well, when you have inverse functions, you can just flip around your x and y variables. Okay. So now what we're going to do is we're going to look at inverse trig functions. So let's see what we remember from chapter 2 in trig. Since I told you guys weren't taking a final in here. Boy, I got to be a softie in here in my old age. We're not taking a trig final. We're just taking a little 4-section quiz. If y equals the sine of x, we start at 0, 0, 1, 0, or pi over 2, 1, 0, negative 1, 0. Okay, we had this going on, right? Why does it look like that? Because it's my cool marker.
I love it.
Oh, literally used that one for a lesson. It was so confusing. It was like red. It's so hard to read.
It's like stars in the sky. Like the northern lights, you know. All right. So if we take the inverse of that stinking function, okay, what would it look like? Well, 0, 0 would still say it's 0, 0. But then 1 would go to pi over 2. So what is pi divided by 2? Is like 1.56, something like that. So this point 1 would go to pi over 2. So what would actually happen is it would go like this. Yeah. So this would flip from here to here, just like this flipped from here to here. We're flipping around the axis here. Okay? So you can. All right. So the sine of x went on forever like this, right? What happens with the inverse or the inverse sine of x is it's stuck in between, its domain is stuck in between -1 and 1 because it kind of goes back. See how this one went back and forth between -1 and 1 as far as y values go? So when you take the inverse of it, it's going to be stuck in between -1 and 1 as far as the x values will go. And inverse, you just flip it on the other axis, basically. Okay? So that's what sine would look like. What would the inverse cosine's domain be? Same thing. Smart girl there. Because the inverse cosine, let's go with lava. Inverse cosine inverse, because the normal cosine would look like that. Yeah, it is. Inverse cosine would look like that. So it would look something like this. Okay? So if y equals the inverse cosine of x, its domain would also be between -1 and 1. Okay? Now, let's see if we can remember what tangent, the inverse of tangent, look like. Yeah, we're going to make another graph here.
Okay, so we're making not so crowded, it looks like really crowded.
Slow down.
No, please give me an example. I want to see it.
Can you just like scroll down? Like...
No,
Yes.
I'm not going to scroll anywhere. All right. Where can tangent not be? Where's the sine over the cosine 1 over 0? Not 0. Where's sine over cosine 1 over 0? Pi over 2. So we have an asymptote right here. And an asymptote right here. And there's going to be an asymptote right there. So remember what... Whoa.
See, it doesn't like your ugly markers either. They're so hard to learn from. He wants us to fail.
All right. So the tangent function, remember, is always positive, so it looks like that.
I thought you said you would fail us for having lines like that.
Well, I guess. All right. So if the regular function looks like this, what would the inverse function? Oh, you guys are getting smart.
Audrey said that like 20 minutes ago. So she's such a smart.
You are. We already know you're smart, Audrey. So the inverse tangent might look like that. Okay? All right. Because it kind of looks like that. But it's going to be in between. Actually, negative pi over 2 and pi over 2. Okay? And that's going to be the range of it. Okay? What? Because you're flipping around. Okay. So, we're going to scroll down now, Nathan. All right. So, if we're looking at what is the domain of the sine, the inverse of sine, the domain was the old range. So, that's in between negative 1 and 1. Okay? And they ask, what is the range of tangent? Well, that's the old domain, which goes in between negative pi over 2 and pi over 2. Okay? Negative pi over 2 and pi over 2. So, this is where we start looking at our unit circle. What's the inverse of the sine of 0? Now, it's asking, where is the sine equal to 0 at? It's at 0. Because at 0, the sine is equal to 0. The arc sine of 1. Arc sine means the exact same thing as inverse of sine. So where is sine equal to 1 at? Pi over 2. Okay? Where is the cosine equal to the square root of 2 over 2 at? Pi over 4. Now, what you must understand is the domains that we're working with. For cosine, our answers have to be between 0 and pi. For sine and tangent, we have to be in between negative pi over 2 and pi over 2. That's where we're working with. Okay, we're working in between those constraints. Okay, so when you give your answers for the inverse functions, that they should be, you should be looking at those parts of the unit circle. Okay, that's important for this. All right. 2B, we get out at 17 after. I got time to talk about this. Okay. So are we good with some of this stuff? So where is the inverse sine negative square root of 3 over 2? Remember, you have to look in between these two. So you have to work from negative 90 degrees up to 90 degrees, just on that half a circle. Where is the sine equal to negative square root of 3 over 2? What? 5 pi over 3, you say, right? It's at 5 pi over 3, but we have to go from 0 down, and we're using degrees. From 0 down. It's at 300, but going from 0 down. It's negative 60 degrees. Okay, negative 60 degrees. Okay, because we have to go from basically negative 90 up to 90 for this. And for cosine, we're going from 0 to 180. Okay? All right. So, where it gets a little difficult is, can you remember where tangent is equal to square root of 3? Well, you should know from the last chapter, where's tangent equal to square root of 3? At pi over 3. So now, where is it equal to negative square root of 3? We have to go down to negative pi over 3. Negative 60 degrees. Okay? Are we good with that? Right? Okay? All right. Where things get a little tricky is, where is the cosecant equal to 2 over the square root of 2? Well, cosecant is the reciprocal of sine. So where is the sine equal to square root of 2 over 2? 45 degrees. And in radians, pi over 4. So if it's a secant of the same place, that's also pi over 4. Okay? Where is the cosecant, inverse cosecant, equal to 2? That means where is the sine equal to 1/2? Pi over 6. You are smart. Okay, so we're good with those. And these are just calculator ones. So that is just inverse. So you push second cosine of 0.938. Okay, so we can handle that, right? Okay, so you get some calculator ones in you. And then we get to the fun ones right here. The tangent of the arc cosine of the square root of 2 over 2. You work from inside out. So what's the arc cosine of the square root of 2 over 2? Where is the cosine equal to the square root of 2 over 2? Pi over 4. What's the tangent of pi over 4? 1. Boom. You got it. See, such smart people in here. What's the cosine of pi over 4? Square root of 2 over 2. What's the inverse sine of the square root of 2 over 2? What's the inverse sine of square root of 2 over 2? Pi over 4. Okay? Not hard. What's the cosine of pi over 3? 1/2, right? So what's the inverse cosine of 1/2? Where's cosine 1/2 equal to that?
5 pi over 3.
Pi over 3. You don't have to go chasing all over somewhere other on some other point in the circle. When we take the inverse of this, it goes right back, doesn't it? So what would the inverse of the sine of 5 pi over 6 be?
5 pi over 6.
Wrong! That's a trick question. What's the sine of 5 pi over 6? 1/2, right? So what's the arc sine of 1/2? Because the sine of 5 pi over 6 is 1/2. They got that right. So what's the arc sine of 1/2?
2.
No! Pi over 6. Yeah, you got this. She don't got this so well.
Thank you.
You're welcome. So you just have to take the answer and plug it back in. Now, something like this, what do you think this one is? It's pi over 9. Because that's not on your unit circle, but since you were in the first quadrant, the inverse of something in the first quadrant goes right back to it. If you're in one of the other quadrants, it could flip around. Okay? So what would this one be?
I'm not answering.
Thank you, Audrey. Pi over 5.
I was gonna, but I'm not. I'm done answering.
All right. This one isn't in the first quadrant, so we might have to think about this one a little longer. Actually, you got it right, yeah.
Are you for real?
What's the cosine of 5 pi over 3? What's the cosine of 5 pi over 3? 1/2. What's the inverse cosine of 1/2? Pi over 3. Okay?
I got that one right.
All right. So you have work to do. There you go.
What? Oh my god. Are we going back to that?
What do you mean, are we going back to that? Yes. We're going back to the computers. Math Excel.
Yes. This is gonna be the most awful. Should I take my nap?
No, because we get out at 17 after, and you need much more time than that to take your quiz test. So,
Okay.
You have like a prep.
yeah, 3A and 3, or I don't have seniors anymore. So I'm open here and I'm open here. 3B and 4B, both.
Well, you have a lot of prep time. Well, you could go in during Spanish.
Because Spanish, you just don't do anything at the end of the year, do you?
It's a catch-up day. It is. Oh, it is. It's a literal catch-up day in Spanish. Yeah.
All I hear is nap time.
If I don't come in.
What period is Spanish? 3B. You can come in 3B.